In this lesson, we're going to talk about linear transformations. We're going to take a new concept and we're going to kind of mesh it with a concept that we learned in Unit 4. So let's talk about these transformations. Basically what a transformation is when you're taking a point or a line or a figure and you're moving it around a coordinate plane in a specific fashion. There are multiple different types of transformations. We're going to talk about translations, reflections, and dilations today. We do not talk about rotations in Algebra 1. So let's go ahead and talk about translations. This is a transformation in which a geometric figure or coordinate is translated up or down on a coordinate plane. Sometimes you do move it left or right, but we're just going to strictly focus on up and down here today. So look at our line here. We're asked to take this line and translate it down 5 units. So I'm going to show you how to do it graphically, and then I'm going to show you how to do it just by looking at the equation. So looking at it graphically, what I'm going to do is I'm just going to pick a point on the line, and I'm going to literally take it down 5 units. So I'm going to go 1, 2, 3, 4, 5, and I'm going to put my dot there. I'm going to go ahead and choose another point, and I'm going to go down 5 units. 1, 2, 3, 4, 5. And I'm going to do that all across my line. So I have 1, 2, 3, 4, 5. And I could continue my slope that I see here. It looks like I have a slope of 2. Or I'm sorry, a slope of 1, 2 over 2. So I'm just going to take it up my page. And that's it. Draw my line. Draw my arrows. And I have translated this line down 5 units. Now, let's just look at it and pretend I didn't have this coordinate plane. All right? All right, let's look at my, my original equation is going to be y equals x plus 4. All right, if I didn't have that coordinate plane, all I would have to do is take that y-intercept, and if I'm moving down, I'm going to subtract, and if I'm moving up, I'm going to add. So in this case, I'm going to subtract 5 units. So my new equation is going to be y equals x minus 1. So let's look at just 2 equations here, and let's go ahead and translate them. This one says translate it up 8 units. I don't have to graph it. I can just look at it. I can take that y-intercept and I can add 8 units since I'm going up. So if I do that, my new equation is going to be y equals negative 2/3 x plus 2. And then the next one, translate down 3 units. Well, this is a horizontal line, right? And it's going across y equals 2. So if I take that number and I'm going to subtract 3 from it, that's going to leave me with y equals negative 1. So I've translated the line down 3 units. Okay, translations I personally think are the easiest of all of the transformations we're going to do. Let's go look at a more challenging transformation because it's going to require some work. Okay, this transformation is called a reflection. And this transformation is in which a geometric figure is reflected across a line, creating a mirror image. This line is called the axis of reflection or the line of reflection. So we're going to focus on reflecting over 2 different lines, the x-axis and the y-axis. So in the first example, we're going to do the x-axis. So I'm going to grab my highlighter real quick, and I'm just going to take a second and I'm going to highlight my x-axis, just to remind myself that that is the axis that I'm going to reflect it over. Now I'm going to look at my line here. My line is y equals 2x plus 4, and I'm going to pick a point on my line. I'm going to take that point and I'm going to run towards the highlight. 1, 2, 3, 4. However many spaces that I count towards the highlight, I need to count away. 1, 2, 3, 4. And then I'm going to plot a nice big point. And I'm going to do that all the way up my line. I'm going to count 1, 2, 1, 2. I'm going to come down here. I'm going to count 1, 2, 1, 2 spaces away. And you're probably starting to see the slope show up. Now, this point right here, he obviously doesn't move, so I'm just going to go ahead and plot him. 1, 2, 3, 4. 1, 2, 3, 4. And I can go ahead and fill in my other dots. Okay, this is my reflection over my x-axis. So visually, that's what it looks like. But now let's look at it according to the equation. And my equation is y equals 2x plus 4. Well, let's actually look at my new equation. It looks like it's y equals negative 2x, and my y-intercept changed to 4. So not only did my slope change, but my y-intercept changed. Both of them went from positives to negatives. Now let's look at the reflection over the y-axis. here's my y-axis. I'm going to do a little highlight just to remind myself that that's my line of reflection. Okay, my original is the same thing, y equals 2x plus 4. And I'm going to go ahead and do the same process. I'm just going to pick a point on the line, and I'm going to run towards that highlight. And then I'm going to run away from it. I'm going to do the same thing here. 1, 2, 1, 2. 1, 2, 3. 1, 2, 3. And then I can go ahead and continue my slope all the way down my page. Okay. There is my reflection over my y-axis. I'm going to go ahead and draw my line. Put my arrows in there. All right, let's see what the new equation of that reflected line is. Y equals, looks like my slope changed to a -2, and my y-intercept stayed the same. So the key thing to know about these two different types of reflections are, when you're reflecting over the x, both the slope and the y-intercept change. But when you reflect it over the y-axis, only your slope changes. All right, let's put this into practice here. Let's do two problems that have some reflections in them. It says, given the graph, reflect the line over the x-axis, and then write the new equation in standard form. So this is where we're kind of mixing this new topic with an older topic we're familiar with. All right, so let's go ahead and we can either do it graphically or we can do it by hand. I'm going to go ahead and write my equation of my line. It looks like I have y equals, looks like my slope is going to be 1/4, and then my y-intercept is going to be -1. From before, if you remember, when we're reflecting it over the x-axis, we're not only going to change my slope, but we're also going to change my y-intercept. So I'm going to change it to -1/4 x, and I'm going to change it to +1. I could also do that graphically. I could show it over here. I'm going to go ahead and grab my highlight, and I'm going to highlight my x-axis. Okay, there's my highlight. And then I'm going to go ahead and do that same little thing that I was doing before. Okay, so that's what it looks like visually and on the graph. So you can see that it's the same exact line that we just wrote. Now I'm going to take it one more step, and I want to put it in standard form. So I'm going to go ahead and I'm going to add my 1/4 x to both sides to get that x on the left. I'm going to bring my work up here to the top. So now I have 1/4 x plus y is equal to 1. And again, I need to get rid of that 4 in my denominator. So I'm going to multiply both of my sides by 4. That eliminates that 4 and leaves me with an x. And don't forget to multiply that 4 by the y as well. So plus 4y equals 4. So that is my my reflected line over the x-axis in standard form. All right, let's try another one. Given the equation of the line, reflect the line over the y-axis this time, and then write your new equation in slope-intercept form. Okay, so my y-axis, and notice I don't have a graph here to look at. I'm just given the equation in point-slope form. Well, think about it. Whenever we reflect something over the y-axis, the only thing that changes is my slope. So let's go ahead and take my slope, and let's go ahead and change it. My new equation is going to be y minus 3 equals, I'm going to change that 1/2 to -1/2. X minus 4. Now let's transfer it into slope-intercept form. And there you have it. Okay, now let's look at the last type of transformation we're going to do today. This is called a dilation. This one's my favorite. So dilation, if you think about those times when you go to the eye doctor and they put a little drop of liquid into your eye and they change the size of your pupil either gets larger or smaller and you can't really see straight. That's called a dilation. They're dilating your pupils. So dilation is just when you're making something bigger or smaller. So in our case, this transformation produces an image that is the same shape as the original, but it's a different size. And the new size depends on the scale factor. A scale factor is a number which scales or multiplies some quantity. So let's look at this first example. It says dilate by a scale factor of 3. Okay, so my scale factor is 3. This is my multiplier. So I'm going to look at my line here, and I'm going to figure out what the equation of that line is. It looks like it's y equals, and it looks like I have a slope of negative 1/4, and then my y-intercept is negative 2. Dilations are very simple. I'm going to take that scale factor and I'm going to multiply that number by my y-intercept. So my new equation is going to be y equals negative 1/4 x minus 6. And that's my dilation. So my new equation is going to be y equals negative 1/4 x minus 6. Let's go ahead and graph it and see what it looks like. There's my y-intercept. And here is my slope. There's my line. Now you may be thinking, that doesn't really look like it's bigger or smaller. It just looks like a translation. Well, dilation of a line looks like a translation. But on the next slide, I'm going to show you what it's actually doing. Let's just look at one more before we do that. This time I have a scale factor of negative 1/2. Let's go ahead and do the same thing we just did. I'm going to write my equation. And it looks like my slope is, it looks like it's negative 3/5. And my y-intercept is 4. I'm going to take that y-intercept and I'm going to multiply it by 1/2. So y equals, oh, I'm sorry, I forgot my x there. Negative 3/5 x. And when I multiply it, it's going to give me negative 2. So again, what it looks like, I'm going to have a y-intercept of negative 2, and then 1, 2, 3, 1, 2, 3, 4, 5. You can also see that they look like they're parallel as well. And I'm going to draw my line. Okay, it doesn't really look bigger or smaller, so let's see why it doesn't look like that. This is just a nice visual for you to see what's actually happening to these lines. Now, for the purpose of the example, I'm just going to show you using coordinate points and an image that's a triangle. So hopefully you'll be able to see what's actually happening here. This dilation, I want to dilate it by a scale factor of 3. Now, when you dilate just simple coordinates, you're going to multiply each of those coordinates by your scale factor. So I'm going to go ahead and do that. Okay, I'm going to go ahead and plot those points so you can see what the dilation's actually doing. I'm going to label my A, that's going to be called A prime. My B is going to be B prime. And my C is going to be C prime. It's going to be a little off my graph, I apologize for that. And I'm going to go ahead and connect these dots because it is a triangle. And I wanted you to see that the dilation is a scale factor of 3, which is an integer number. That's going to make my triangle dilate to make it bigger. If I were to multiply it by the scale factor of 1/2 or 1/3 or 1/4, it's going to make it smaller. So if you think about this when it comes to a line, watch what I'm going to do here. I'm just going to take a second and I'm going to erase this line so you can just look at my line AC, and you can see if I just cover up, see if I can do this. If I just cover up all of this over here, look at my AC and then look at my dilated AC. It didn't necessarily get bigger, but it was dilated, and you can see that on the coordinate plane here. So that's kind of the idea behind a dilation, what's actually happening. Let's try 2 problems with dilations. These are really fun problems. Given 2 points on a line, 1, 1, and 3, -5, dilate the line by a scale factor of 6 and write the equation of the new line in slope-intercept form. Okay, well, you're probably thinking, from last unit, we learned that if we have 2 coordinates, we can get a slope. So let's go ahead and find my slope. This is my x1 and y1, and this is my x2 and y2. So I'm going to go ahead and take a second and solve for my slope. Looks like I have -6/2, which is going to give me a slope of -3. And I also need a y-intercept. So you can do multiple avenues. You could go the point slope route, or you can do the y equals mx plus b route. So I'm going to go ahead and do that. I'm going to say 1 is equal to negative 3 times 1 plus b. 1 equals negative 3 plus b. I'm going to take my work up here. Let me rewrite that. And I'm going to add 3 to both sides. So my b is going to be equal to 4. Well, now that I have a slope and I have a b, I have an equation. Y equals negative 3x plus 4. Now, that's the line with those 2 points. So those 2 points run through this line. But now I want to dilate the line by a scale factor of 6. So I'm going to take that y-intercept and I'm going to multiply it by 6. So I'm going to end up with y equals negative 3x plus 24. And that is my new dilated equation. Here's another cool one. Dilate by a scale factor of negative 2, and then write your new equation in standard form. Okay, well, it looks like this is not in any particular form, so I'm going to actually translate it into my slope-intercept form. So I'm going to start by doing, I'm actually going to do, well, yep, we'll do that. I'm going to add 15 to both sides to get it over onto the right-hand side, and that leaves me with negative 7x plus 5y equals 15. And then, of course, I'm going to move my x over to the other side as well. So 5y equals 7x plus 15. Okay, and now I'm going to go ahead and divide it by 5. This work is all to get my slope-intercept form of my equation. So I have y is equal to 7/5 x plus 3. Okay. Now that I have my equation, I want to dilate it by a scale factor of negative 2. I'm going to take that y-intercept and multiply it by negative 2. That's going to give me y equals 7/5 x minus 6. But we're not done. We have to put it in standard form. So I'm going to go ahead and subtract 7/5 x from both sides. Now I have negative 7/5 x plus y equals negative 6. And I'm going to go ahead and I'm going to multiply both sides by negative 5 to get rid of my negative and to get rid of my denominator of 5. This is from last unit. This is a good review of that. Minus 5y equals positive 30. So this is the equation of my dilated line. All right. I know that was kind of a longer lesson, but feel free to go back and take a look at some of those details and check out those transformations.